Welcome to the Deep Dive. So today we're unpacking a discussion that, it really sits right at the intersection of economic need and national vision.
It does.
We're talking about Jamaica, which is at a serious crossroads. You've got housing, affordability, and this fundamental question of human dignity all wrapped up together.
And right in the middle of that debate, the question is now, should shipping container homes be a real, scalable national solution?
It's a huge question.
It is, and the source material we're looking at today is particularly insightful. It comes from someone who really understands the stakes. A chartered builder, a project manager, surveyor, realtor, someone who's worked with buildings, land, and people for decades.
So not just an academic view, this is grounded.
Absolutely. And for this professional, housing is never just about, a quick roof over someone's head. It's framed as a decision about legacy.
Legacy, that changes the whole conversation.
It's a long-term investment in the country's future.
Right. And that's really our mission in this deep dive. We want to give you, the listener, a kind of roadmap to evaluate this whole thing seriously. We've got to move past those initial knee-jerk reactions.
You saw them immediately.
Oh, yeah. The excitement on one side, that they're modern and quick, versus the dread on the other, that they're just going to be hot, unlivable metal boxes.
Exactly. So we need to dig into the precise engineering realities that would make these things actually work, sustainably and comfortably in a tropical climate.
And the central idea here, as the source points out, is pretty simple.
It's liberating, really. The idea is that no building system is automatically good or bad.
It's what you do with it.
It's all about what you do with it. Concrete, timber, steel. It doesn't matter. So when we talk about container homes, we have to fundamentally shift away from this idea of a simple box and start treating it as what it has to be. An intentional, climate-adapted, engineered system.
Okay, let's unpack this. So when the government first floated this idea, you saw those two opposing reactions just collide.
Instantly.
On one side, all this excitement, this sense of innovation, speed, a modern kind of aesthetic.
But then the other image, the one that causes immediate and, frankly, justified alarm, is the idea of the sufferation box.
And that's a powerful image.
It is. People just picture this uninsulated metal shell, dumped on a lot, radiating tropical heat with zero comfort, fundamentally lacking dignity.
And that fear is rooted in reality if the job is done badly.
It absolutely is. I remember this source professional mentioning they'd seen an early prototype where the residents had to. They jury-rigged a heavy, dark tarp over the roof.
Just to block the sun.
Just to stop the metal from radiating heat down into the room. And that crude image, that low-dignity solution, that's the benchmark we have to fight against with professional design.
So how do you fight that? What's the potential for a dignified design?
You fight it with architecture. The source has seen and conceptualized some really stunning results. Homes with clean industrial lines, large, bold glass openings, professionally cut into the steel.
So not just a square window.
No. And crucially, proper exterior cladding. That could be wood or cement board, but it creates both an aesthetic barrier and a necessary thermal barrier. We're talking clever cross-ventilation, timber decks that push the living space outside.
Rooftop terraces even.
Even usable rooftop terraces. Done correctly, they become spaces of really high dignity.
And that design quality is often driven by the very limits of the box itself.
Right.
That define 20 or 40-foot structure.
Precisely. Unlike traditional building where you start with a blank slate, the container, it forces creativity.
It's constrained.
It imposes a defined geometry, which, paradoxically, pushes good designers to maximize every single inch. You get these very functional, minimal, yet really appealing spaces.
We should probably tie this into the recent economic history, because it explains why we're even having this discussion now.
For sure.
Around 2021, you had this container craze really take off in Jamaica. It seemed like the quick, affordable answer.
It really did, until the global supply chain crisis hit, and then the prices of shipping containers just spiked dramatically.
What kind of numbers are we talking?
Well, a used 40-foot high-cube container, that might have been, say, $2,500 pre-pandemic. It suddenly shot up to $8,000 or even $10,000 for a time.
Wow. And when your basic raw material triples or quadruples in price.
The whole economic argument for a one-container solution just collapses.
It breaks the model.
Completely broke the quick and cheap model.
Yeah.
The math just stopped working. So now that prices have come back down, the conversation's returning. But we have the benefit of that experience.
Right. It taught us the focus can't just be on the short-term sticker price of the box.
It has to be on the long-term engineered viability of the home.
So if the short-term economics aren't the main advantage anymore, That forces us to look at the long-term integrity. And that brings us to the system, all the components you need to turn a box into a building.
Absolutely. The system is comprehensive. We're talking about coordinated engineering decisions, about the foundation, structural reinforcement of the steel, the climate, orientation, insulation,
All the utility safety standards.
services, safety standards, cladding, internal planning. It's a whole process.
Which sounds incredibly complex. And that runs completely counter to the public image of a container home being some quick, throwaway solution.
It's the difference between a real project and just a process. This is not like knocking up a board house in a weekend.
Right.
Or just dropping a trailer on a plot. This requires controlled, precise, intentional engineering. When you cut a huge opening in the side of a container for a glass door, you have just structurally weakened it.
And you have to fix that.
You need professional certified welding and reinforcement. It's like structural therapy for the box itself.
Let's spend some real time on foundations, because they are the unsung heroes of longevity, and Jamaica has this incredibly challenging, varied landscape.
It's so varied. You have coastal areas, you have coral stone, alluvial plains, volcanic rock, steep mountain slopes.
Karst limestone.
Huge areas of karst limestone.
Yeah.
So the foundation decision is site-specific, and it is non-negotiable.
If you get that wrong.
If you get the base wrong, everything you put on top of it, no matter how clever, becomes a very expensive liability.
And it has to be engineered for what specifically?
Two primary threats: hurricanes and earthquakes. You have to assess the soil's depth and its bearing capacity, how much weight it can actually support safely.
And when you list all those different types of terrain, I can just see the cost skyrocketing depending on where you're trying to build.
Precisely. Let's just take two examples. If you're building on stable volcanic rock or dense coral stone, you might get away with a simple, pretty cost-effective strip footing, maybe a small concrete slab.
Okay.
But if you're building in those coastal alluvial plains, that loose, sandy, water-saturated ground,
You need to go deep.
you need deep steel piles or engineered concrete piers to get down to stable bedrock. And that second option can cost 2 or 3 times the price of the first. The speed advantage of the container is often just canceled out by the foundation work.
That immediately fills in a huge gap in the economics. It's not the price of the box, it's the cost of anchoring the box to the earth.
Yeah. And if you're near the coast, you've also got salt air corrosion, rising water levels, and a serious risk of flooding.
So you have to elevate.
Which means the foundation has to elevate the structure. That adds complexity and cost, but it ensures long-term safety against extreme weather.
Here's where it gets really interesting. Okay, so once it's anchored, we have to deal with the most immediate comfort factor, which is heat. So the big question, are containers hot?
A bare container, yes. It's a heat trap. It is a huge steel radiator sitting under a relentless tropical sun. But
There's a but.
as the source material really stresses, the solution is entirely in smart, climate-responsive design choices.
Which means understanding the environment is step one of the design.
Absolutely. The principle is clear. The wind is your free air conditioner, and the sun is both your best friend and your worst enemy.
I like that.
So the design has to consider the prevailing breeze. Where does the air come from? Where does it go? You need sun studies to design proper shading, deep overhangs, and to optimize every single opening for natural cross airflow.
All to reduce that afternoon heat.
If you ignore the sun's path, you bake the residence. It's that simple.
Now, the source material makes a statement about this that is just.
Yeah,
It's strikingly clear. It's non-negotiable.
it is.
Without proper ventilation and insulation, a container home in Jamaica will not work.
That is the absolute minimum standard for habitability, and we have to treat those elements with engineering rigor, not just as, an afterthought.
So ventilation can't just be random.
No, it needs strategic placement of windows and vents to ensure true cross ventilation.
Meaning you need air coming in one side.
And escaping out the other, you need the air to actively move across the living space and get out, creating a constant thermal siphon. If you just cut a couple of windows on one side, you're just trapping heat.
And you have to think about where you are.
Right, the climate zone, the elevation of the site, the prevailing wind strength, all to make sure that natural airflow happens reliably.
And then insulation.
Because steel is such an efficient conductor, insulation is mandatory. We can't just paint the container white and call it a day.
What kind of materials are we talking about?
Things like rigid foam insulation, rock wool, spray foam, or ideally external cladding systems that are designed with an air gap between the steel and the cladding itself.
Ah, so there's a space.
That air gap is critical. It stops the sun's energy from transferring directly to the steel box. Only by respecting these physics can the container actually be cool and comfortable enough for someone to live in long term.
Okay, let's talk scale and modularity, because this is where the system really becomes a home, especially for larger families. A single 20-foot container is a tiny studio.
Very small.
A 40-foot box gives you a compact space, maybe for 1 or 2 people, but it's not a family home.
But modularity is the container's greatest asset. I mean, they're literally designed to be stacked, shipped, and joined. And when you join them, you break free from that restrictive 8-foot width.
So how does that look in a practical family design?
Well, if you take two 40-foot containers, you can separate the living space from the sleeping quarters completely. You can join them side by side and cut out the interior wall to make a big open-plan living room.
Or arrange them differently.
Or you can place them parallel with a gap in between, connect them with a roof, and you've just created a sheltered internal courtyard. That's where it starts to feel like a real home.
Maximizing light and breeze.
Exactly. And if you move to 3 or more containers, the possibilities just explode. You can easily do split-level 2-story designs. You could dedicate one container just to utilities, storage, bathrooms. You can create these extensive layouts with wraparound verandas that integrate into the landscape.
The source professional put it really well.
They did. 1 container is a room. 2 containers start to feel like a home. 3 or more let you tell a proper story with space.
And the important caveat is still there. Every time you cut, join, or stack.
You're increasing the engineering complexity and you're increasing the cost.
Right. The structural integrity has to be certified constantly. It's not just about fitting furniture in.
No, it's about meeting national building codes and making sure that structure can survive a Category 4 hurricane.
Which brings up that fundamental question of longevity. Are we building something temporary or something permanent?
Mm-hmm.
The source material argues that if it's temporary like emergency shelter, it has to be treated that way.
And not quietly sold as a long-term home.
Right.
The real danger is when a structure that was designed for maybe a few years is forced by circumstance to serve for a whole generation. A home engineered to last 50 years needs vastly different materials and quality control than one built to last 5.
So for a permanent 30-plus year product, what are the quality assurance non-negotiables?
Rigorous certification is key. All the welds, all the structural reinforcements have to be done by certified professionals. The cladding must be protective, not just decorative, to shield the steel from salt air and stop corrosion.
Which would kill the lifespan of the structure.
Dramatically shorten it. And then every utility system, electrical, plumbing, fire safety, drainage, it all has to meet permanent safety standards.
This all loops back to the economics and the need for a deeper analysis, moving beyond that simple cost of steel argument.
Absolutely. The economic question has to shift from, can we afford this container today, to, is this system cost-effective over its entire lifetime?
And this is where the poorly engineered ones fail.
This is exactly where they fail. If you skip proper insulation to save, say, $2,000 on the initial build, you will end up paying $500 more per year in electricity for the next 20 years just to run the air conditioner. You've completely negated the initial saving, and you've created an energy liability for the owner.
That is a powerful way to frame the hidden costs of cheap construction.
It is. The nation just can't afford to roll out huge programs based on cheap, unregulated products that will fail the people who live in them. We need solutions that are scalable, appropriate for Jamaica's very varied terrains, and genuinely sustainable.
And underneath all of this, whether we're talking containers or concrete blocks or timber, is the principle of dignity.
Without a doubt. Good architecture isn't some optional extra. It's about providing comfort, safety, and self-respect to the inhabitants.
Yeah.
If container homes are done well, with proper engineering, beautiful design, climate adaptation, they can be uplifting. They can represent progress. But done badly, uninsulated, cheap, uncomfortable, they fail as housing and just serve as a constant reminder of hardship.
So we have to choose dignity.
At every single step of the design and build process.
Okay, so to summarize the key takeaways for you listening, if Jamaica does decide to move forward with container homes at scale, the focus has to be entirely on doing it right.
Not just fast, not just cheap.
Right. That means a strict checklist.
Yes. Proper structural certification, deeply climate-responsive design, mandatory and serious ventilation and insulation strategies.
Suitable elevation for flood and seismic risk.
Materials that can resist the tropical elements, and crucially, scalable layouts that actually work for diverse family structures.
So what does this all mean?
It means we don't need a single silver bullet solution. We need a basket of solutions.
Okay.
Jamaica's geography, its climate extremes, its family structures, they are just too diverse for a one-size-fits-all approach. Container homes can be one useful, highly modular tool in that basket.
But just one tool.
Just one tool among others, and we have to remember the container itself is just the starting point. The care, the respect, and the professional thought that goes into turning it into a lasting, comfortable home, that is what will ultimately determine its success.
Which leaves us with a final provocative thought for you to consider. Given that large families will need to join 3 or more containers, and the fact that these permanent modular systems still need the same high-cost hurricane and earthquake-resistant foundations as any traditional building, how does the final lifetime engineering cost of this modular system really stack up against conventional block and steel construction in the long term? Especially once you factor in that 30 to 50-year durability and the ongoing maintenance of a steel structure. We'll leave you to think about those complex lifetime economics